Hello everyone. Today we'll be discussing about interfacing and decoding modulated IR sensor with Arduino. At the end of this session, students will be able to interface modulated IR sensor with Arduino and decode the communication protocol using logic analyzer. Here is the interface diagram.
Okay, so as you can see, this is the same practical setup that was discussed in our other videos, where we were talking about the Fresnel lens and the way how this can be used for identifying or detecting a motion just because of the presence of this Fresnel lens. Not only that, but also whenever you are dealing with any sort of motion detection based sensors that you are trying to build by using any IR LED and transmitter or photodiode just of this kind. So under those conditions, when you are trying to build your own motion detection sensor by using an IR LED and a photodiode, the problems that usually one faces while designing is, no matter that these IR LED transmitters are not visually what we can call they're not, I mean, the IR radiation is not visible to our naked eyes, but definitely you can see it through your cell phone cameras or so, just for the sake of checking. But the problem appears in those circumstances where you are trying to read the IR diode reflections through some sort of photodiodes or maybe a photo receptors that doesn't have any sort of masking. So by saying masking, we can say, like, for instance, if I'm using this sensor, something like this, as you can see here I have an IR transmitter LED, and here I have a photodiode. So this particular black appearing diode is nothing but this is a masked IR photodiode, which is going to be activated only when I get a reflection from this IR LED. So imagine that I have some obstacle somewhere here and I'm placing the sensor. Then probably this is going to transmit the IR radiation that is going to be reflected and echoed back, and this is going to sense it. But the reason why this is colored black is that so as to mask it from regular daylighting. That could be a very good and a cheap way of masking the IR radiations or the faulty IR radiations that usually appear to be a part of our regular day-to-day sunlight. This is going to create a problem. Like, for instance, imagine like you are designing a small line following robot and you have decided to use these kind of sensors because they are the cheapest one. As you can see on the back side, there are absolutely no additional components. It's just a PCB that contains two LEDs, and maybe if you feel like there is some droppage in the voltage, then probably these LED pins can be taken down to an operational amplifier, and then they can be amplified and fed back to the microcontroller. But you can even use this roughly for getting a rough estimate of whether you have an obstacle in front of you or not. So the major problem that every engineering student or anyone that is using this kind of sensors faces is that, for instance, let us assume that you are working at a night or during a dark time by turning on your light bulbs in your home, and at that moment you decided to set a certain threshold to this photodiode. Like, for instance, if this is emitting IR radiation at an 80% and you are getting some 20% of the reflection back, maybe the just because the surface is absorbing some sort of the energy, then you are going to set this for the incident energy that is appearing on this photodiode. But here the problem is, if you are setting it to 20% incident energy, whenever it appears, or that seems to be incident on this particular photodiode, that is going to be activated, and hence you're going to set all rest of the parameters, like setting the potentiometer thresholds, considering the voltages, your amplifiers, and all these things. But on the other day, you will find that this same threshold and the sensor that you have programmed and which was working absolutely fine the earlier day during dark time is now behaving abnormally. The reason is, maybe if you are working in different incident light zones, like once you are operating your robot in which you have imparted this particular sensor, under sunlight that may appear differently, under shadow that may appear to behave differently, and under your light bulbs or LED incident lighting that would behave differently. The reason is, these masks or the colored masking scheme doesn't work properly. So is there any solution for this one? Yes, there is absolutely a solution for that one. One thing is, you can either use any sensor of this kind, which we usually call as passive infrared sensors, and but these kind of sensors are usually uh, intended to be used with a Fresnel lens, and they have to be used only for motion detection. So apart from this, if we are interested in using or solving the problem of these kind of sensors of not behaving differently in different daytimes, then we have a solution of using these kind of sensors. So what is the difference between these two? The basic difference between these two is, here you have an IR transmitter, here also you have an IR transmitter, but here you have a photodiode that is masked, whereas here we have an IR receiver, which is also a kind of a PN junction ultimately, but you can look at the package how it seems to be. Okay, and these are the same devices, these are the same electronic components that tend to capture your remote control signals on your TV, or maybe your any remote IR remote controlled gadgets. So you can consider, you can pause this video for a moment and think on what exactly, I mean, what kind of modulation technique is actually used, such that only the remote that belongs to that specific gadget is able to capture the signals. Otherwise, it would have been very difficult. You're trying to turn on your TV and your refrigerator is turning off, or your ceiling fan is turning on randomly for a given action. For a given cause, multiple actions are happening. So to talk about more specifically about this particular component, this comes into various packages, either TSOP 1738 or TSOP 1725. There are specific numbers and terminologies used for identifying these electronic component or the packages. This is nothing but an IR receiver, which is usually present in all those electronic gadgets which are responsible for getting controlled through an IR remote, something like this. So even if you consider any remote like this, here you have a IR LED. This is the same LED, as you can see. Whenever I'm pressing it, the camera is able to capture. This is an IR light which is not visible by a naked eye. As you can see, I'm continuously pressing this. This is the IR incident light. So whenever you press any button on your remote, every button has a specific coordinate, or every button has a specific code. That code is actually time modulated, and that is coded into a microcontroller of this kind. And whenever you're pressing a button on your remote control, that is transmitted with a specific frequency. So for instance, if I consider this particular component, which is an IR receiver, this is working on this is working at 25 kilohertz. So for instance, if I say like I'm getting into the daylight on a sunny day, and I'm saying like, today the frequency of sunlight is too high, or the frequency of sunlight is too low, that doesn't make any sense, right? So sunlight, we assume that it doesn't have any frequency that is being continuously emitted. So On the other hand, if I consider this kind of sensor, this is going to emit a continuous signal, whereas these boards are designed in such a way where you can see that there is a small IC. Most of the times this is either an operational amplifier or a timer IC. We can use any sort of IC, or we can even directly interface these components of transmitting and receiving the IR signals responsible for dealing with the IR stuff directly with the controller, and we can even program it in such a way that it will transmit at a specific frequency so that this component can receive the signals at a specific frequency. So the moral of the story is that this IR LED is programmed to emit a specific modulated signal, and these components are already manufactured to capture the IR signals at a specific frequency. So as of making this video, I am aware that there are 2 to 3 variants, especially 25 kilohertz and 38 kilohertz are the most common ones that are found in the market. So these are the boards which can be directly interfaced with any sort of microcontroller of this kind. And again, the method and the program that you're able to see in our previous videos where we interfaced this sensor are one and the same. Just replace this with a modulated IR sensor of this kind, and that's enough. But this sensor on the other hand has a long distance, whereas this has just 4 to 6 inches of obstacle detection capacity. So this is a proximity sensor that has the modulation, signal transmission and reception capabilities, and because of which this can work in any sort of lighting.
Here are the references used for this video. Thank you.